to fill in a sample space diagram. So the sample space diagram is shows us that what is the total outcome possible, what is the sample space available with us. So here are a spinner, and the spinner has four sides. So R, G, B, and Y, right? And a six-sided die. So here is a six-sided die written 1 to 6, and the spinner has these ones. So if you are going to throw a die and you have to spin a spinner, then what can be the likely outcome of combinations? On the spinner, you can get R, and on the die, you can get 1. Or the another combination can be on the spinner, you can get G, and on the die, you can get 1. Or another combination can be on the spinner, you can get B, and on the die, you can get 1. Or on the spinner you can get Y, and on the die you can get 1, because both of these are being done simultaneously together. Okay, so or there can be another combination with the R is 2. R and 2 can also be, and G and 2 can also be, B and uh, 2 can also be, and Y and 2 can also be. So in the same way, you have to fill all of this sample space diagram. One is a spinner, and the other one is a spinner which has four sides, or there is one more die, and there is one more dice which has six options or six sides on it. So the sample space diagram will have the options of 6 times 4. Total 24 are the likely outcomes, or 24 are the likely combinations. So the sample space here has 24 options in all this. So you can just fill all these and you can know that what all can be the combinations. In question number 2, it says that the football club has members, uh, 10 members whose favorite subject is history, 9 members whose favorite subject is French, and 21 members whose favorite subject is English. So we have to first find how many are the total members in the club, right? So 21 plus 10 plus 9, and it gives us 40. So the total members in the club are 40, and the question says find the probability of choosing a member whose favorite subject is French, right? So the probability of French will be the number of people. So those people are nine. Nine whose favorite subject is French. So 9 out of total 40, right? So 9 out of 40 is the probability of people who like French as a subject when they are chosen as a random. So whenever you find the probability of something, you have to look for the possibility of success, or the possibility of achieving that success divided by the total number of outcomes possible. Probability that wins is 0.5, and find the probability does not win. Probability of not winning is 1 minus probability of winning a game, right? So because the lily can either win the game or does not win the game. So the probability of not winning is 1 minus probability of win is 0.5, and this should give us zero point 0.5. So the lily has 50% chance of winning, then that means she has a 50% chance of losing. If probability has a probable if the probability of win is 0.25, then probability of not winning will be 0.75 because both of these probabilities should sum up to 1. Okay, in the next question, we have been given a sample space diagram in which there are two dies, and one die has six sides, and the other die also have a six sides. So here you see one die and other die also have a six sides. So we have 36 sample spaces here. So total possibilities are 36. When we roll two dice, both of them have six sides each, then we have the sample space available with us is uh, 36. Sample space is 36 available with us, and it now the question says find the probability that Joel gets a number which is 7 or less. So we have to include the 7 or less. So here is the 7 or less. These are the numbers 7 or less, including 7 or less, the probability. So how many are the numbers in 7? So the probability of 7 or less is equal to 21 over out of 36. So 36 is the probability of total sample space, and probability of getting 7 or less is here 21. So these 21 numbers are here. So we can further simplify and divide the both sides by 3 to get it 7 over 12. So 7 over 12 is the simplified answer of the probability. In question number 5, it says the table shows the pupils chosen at random studies Spanish, Portuguese, Russian, Chinese, or German. So Spanish is 0.35 here, and Chinese is 0.15, and German is zero point 0.2. And there is a condition that the probability of Russian is twice is likely is Portuguese. So if the Russians students are, uh, if the Portuguese are 2, probability of Portuguese are 2, then the Russian will be 4 because Russians are twice. Russian is twice, likely is for Portuguese. And if the Portuguese are 10, the Russian will be 20. If the Portuguese are 20, the Russian will be 40 because the Russian are twice of Portuguese. So, and when we sum all the probabilities, the answer should be just 1. Okay, so here the sum of all the probabilities should be 1. So the probability of Portuguese and Russian should be 1 minus probability of Chinese, German, and Spanish. So if we add 0.35, 0.15, and zero point 0.2, it gives us 0.7. So that gives us 0.3. So 0.3 is the probability of Portuguese and Russian, but we have to distribute this point 0.3 in such a way that the Russians are twice as compared to the Portuguese. So if it's point 0.3, so two portions to Russian and one portion to Portuguese. So point 0.20 is the Russian probability and Portuguese probability is 0.10. Okay, in the next question is also a similar kind of a question in which it asks for a relative frequency. So the relative frequency is also called experimental frequency. Experimental frequency. And when you conduct an experiment and your outcome from that experiment divide by total trials is called the experimental frequency or the relative frequency. So Nick selects people from the list of 200 from at random 200 times and records the number of pupils who studied German, Spanish, Russian, or Portuguese. And then he finds this one. The Germans were 20, Spanish were 30, Russian was 60, and Portuguese were 90. And if you add all these 90 plus 60 plus 30 plus 20, it's these are the 200 people. See, okay, relative frequency of Russian is equal to 60 divided by 200. Or in other words, if you simplify this one, it gives you 3 over 10. In question number 7, the table shows each of the probabilities that a counter taken at a random will be black, white, red, green, or a purple. So if you take a counter right from of different colors, for example, there is a bag in which there are different counters. Those are black, white, red, green, or purple, and the probabilities of each is given, right? So the probability of getting black is zero point 0.1, getting white is zero point 0.2, getting red is 0.25, and green is zero point 0.1, and purple is zero point 0.3, right? So Charlie selects a counter at random 200 times. Okay, so work out an estimate for the total number of times a counter will be green. So probability is equal to outcome divided by trials, total number of trials. Here, the probability is given to us here, and trials are given to us, and we have to find the outcome. It will be green, right? So green outcome is equal to probability times the trial, probability times the trial, probability times the trials. So here is like probability of green is zero point 0.1 times 200, and this gives us 20. So there will be 20 guesses. Libby has 15 purple balls and 5 red balls in a bag, right? So 15 purple. So if there are the purple balls are 15 purple balls and 5 red balls in a bag. Okay, so Libby takes one ball at a random from the bag, put it back, and takes another ball from the bag. So total the balls there are 20. So the probability of purple being a purple is 15 out of 20. And probability of not being a purple is 5 out of 20. And when she takes the ball, then puts back it inside, and if it was a purple for the first time and in the second time again the probability remains the same. There is no change of probability of a purple and not being purple because the ball has been put back into it. So if it was a not purple, then even then, the probability of both purple and non-purple remains the same. So complete the tree diagram, which we have completed already. So this is how you can complete for both of the tree diagrams. In question number 9, it says Lois has one white sock and 9 green socks in a box. So the probability of white has been given as 1 out of 10 because total 10, and not white is 9 out of 10 because total number are 9, 10, and 9 out of 10 are not white because 1 is white and 9 are green. So not white means it's not, it's a green is 9 out of 10. Louis takes one sock at random from the box, put it back and takes another sock from the box. A tree diagram is shown to represent the information. So find the probability that Louis takes two white socks, right? So two white socks is here. The probability of getting white in the first attempt is 1 out of 10. So if he gets a white sock, then he puts it back, and then in the next attempt, this is the first try and this is the second try. So in the first try, he gets 1 out of 10, and in the second try, he gets again 1 out of 10. So the probability of getting two white socks. It says two white socks. That means white here and white here. So we have to go on this branch here and then on this branch here, right? So probability of white and white. So probability of white and white. So if the probability of white and white, then we have to time them. 1 out of time, the probability of white for the first time, and the probability for the second time is again 1 out of 10 is equal to 1 out of 100 is the probability of getting white and white. Okay, so these two events are independent. Okay, if the two events are independent, then they time together. If the two events are mutually exclusive, then you have to add them. So the mutually exclusive are the events which cannot happen at the same time. Mutually exclusive are the events which cannot happen at the same time. Cannot happen, right? Same time. Like getting white and not white. These are mutually exclusive events, because if you pick a sock from the bag, either it can be white or it cannot be white. So both cannot happen at the same time. So these are, you can call it probability of white or not white. Probability of white or not white. In this case, you have to plus them. Probability of white plus probability of not white. So when the events are mutually exclusive, you have to add them together. And uh, when the events are independent, then there will be probability of white and white. So when there is and, you have to probability of white times probability of white. So means add both the probability and means you have to multiply both the probabilities. So the answer here will be 1 over 100. Libby has two white balls, two green balls, yes, and one red ball in a bag. So two white balls, two green balls, and one red ball. And one ball at a random from the bag. puts it back and takes another ball from a tree diagram is shown to represent the information. So the white and not white is given here. The probability of white is 2 balls and the total is 2 plus 2 and 1 5. 2 out of 5 probability of white is 2 out of 5. And then again, if Libby gets white in the first try, right? If Libby gets white in the first try, in the second again the probability remains 2 out of 5 and not white is 3 out of 5. And if Libby gets in the first attempt not white, which is 3 out of 5, so in the second attempt the probability remains the same. Probability of getting white is 2 out of 5 and not white is 3 out of 5. So find the probability that Libby takes at least one white ball. So at least one white. At least one white means it should not be two whites or it should not be two not whites. At least in both of these attempts, at least there should be one white. So that's only possible if you go on this branch of the tree and on this branch of the tree. First is white, second is not white. And if you go on this branch of the tree, not white, and then on this branch it's white. So in these outcomes, in these two outcomes, in these two branches of outcomes, there is only one white, at least one white here. Other branches, if you go to this branch, I will just do it this way. If you go to this branch, so here no white, at least there should be one white. And if you go on this branch, here are two whites, right? So the red one is the branch which we need to work out. So now, how do we work out this type of questions? So the first one, probability of white and probability of not white. These two are independent events. They are not mutually exclusive. So we write probability of white and not white is equal to probability of white is 2 out of 5 times not white is 3 out of 5, which gives us 3 twos are 6 out of 25. And probability of on the second branch, if we see not white and white, not white and then white, the red one, not white is here 3 out of 5 and white is 2 out of 5. So it again gives us 6 out of 25. Now, these two branches are mutually exclusive, right? They cannot happen at the same time. If it's a white, it cannot be not white, or if it's not white, it can be not be white. So they are mutually exclusive. So when the two events are mutually exclusive, then you have to add them together. So these two probabilities, because it says at least one ball, so at least one ball is here and at least one ball is here. So these two probabilities or these two events are mutually exclusive here. So we will add probability of at least one white is equal to 6 over 25 plus 6 over 25, and that will give us 12 over 25. So this should be our answer for this. So we have got one more question, and in this question it says that 4 green, 3 yellow, 3 black socks, one sock keeps it, okay, keeps it and takes another sock from the box. Complete the Venn diagram. Okay, so green and not green. So the probability of green is 4 out of total 4, 5, 6, 7, 8, 9, 10. 4 out of 10 is probability of green, and not green should be 6 out of 10, because the remaining out of this is not green. And now it says that he takes out one sock and keeps it. So if he keeps it with himself, so in the first attempt, he gets a green sock. So there is a bag in the and it there are green socks, there are yellow socks, and there are black socks. So the probability of green is 4 out of 10, and in the first attempt he gets a green sock out. So and he keeps it, he does not put it back inside, so he keeps it outside. So inside the bag, now in the second attempt, how many green are left? One green is gone. Total there were four greens. So now three greens are left in the bag, and the total also one has decreased. Previously the total there were 10 socks, now there are 9 socks left. And not green, right? There were 6, so the 6 remain the same, whereas the total has reduced to 9. So this was the first attempt here. In the first attempt, right? So he had 4 out of 10 green. So the probability of green was 4 out of 10. And probability of not green were 6 out of 10, right? 3 yellow and 3 black makes 6. So 6 out of 10 were not green. So if we assume that in the first attempt he get a green one, so in the second attempt the probability of again getting green is 3 out of 9, because one green he already got here, he did not put it back. So 3 out of 9, and probability of not green is 6 out of 9. So now we come to the second option, in which in the first attempt, if he had not green, so the probability of not green should be now reduced to 1, because 1 is left outside, so it should be 5 out of 9. The total are now 9, because one sock which he took out was not green this time. It was not green. So the probability of not green has reduced to 5 out of 9, and probability of green remains the same. They were previously 4, so they are still 4, but the total number has reduced to 9. So in this way, so the question asks for only to complete the diagram which we have completed, but sometimes they can ask you to find the probability of two greens, right? Green and green, probability of green and green. So in that case, you have to uh, time this probability of green 4 out of 10. 4 out of 10 times probability of green is 3 out of 9. So that will give you 4 threes are 12 and 10 nines are 90. Or if you want to simplify, 4 out of 30, or 2 out of 15. So this can be further simplified. Or if they say probability of not green, so then you can say this not green here and not green here. So 6 out of 10 times probability of not green and not green and not green. So it will be 6 out of 10 times 5 out of 9. That give you 30 out of 90, or 1 out of 3. So this will be probability of not green. Or if they say probability of at least one green, right? Probability of one green, then you have to solve the same way. First, not green, green, this tree, this branch of tree, and green and not green, this branch of tree. Or they can say it probability of, and it says the Tom has 4 yellow counters, 7 red counters, 9 white counters from the bag, keeps it and takes another counter from the bag. Find the probability takes two counters that are not yellow. So here they have not given you so yellow. You have to find yourself the probability of yellow and not yellow. Okay, so the probability of yellow is 4 out of total how many? 20. 9 plus 4 is 13 plus 7 is 20. 4 out of 20 is yellow. So not yellow is remaining out of 20, right? So 16 out of 20 is not yellow. So in the first attempt, so if these are the probabilities, so there's a second attempt as well for yellow and not yellow. And if it's not yellow, then there are again yellow and not yellow. So keeps it. Remember these. If he keeps it, that means he does not put it back inside. So in the next attempt, one probability will reduce. So probability of yellow will be 3 out of 19 and probability of not yellow will remain the same 16, but the total has reduced to 19. And here also, if it's not yellow, then the not yellow will reduce to 15 out of 19. And here the yellow will remain the same 4 out of 19. So these are the probability trees, and we have to find the probability takes two counters that are not yellow. So this is not yellow, right? So here this is not yellow, and again this is not yellow. So we have to probability of not yellow and not yellow is equal to 16 out of 20 times uh, 15 out of 15 out of 19. So if you time these two together, you will pretty much find the probability of not yellow and not yellow. So if you want to do it, 16, 15 times 16, 15 times 16, 240, 240 times 0, 9 twos are 18, 1 carry 23, 380, or in other words 24 over 38, and you can further simplify. So this can be your probability. So the last question is about a Venn diagram, and the Venn diagram shows the number of students studying various subjects of 100 students. So the total number of students here is 100. Universal set here is a 100. Okay, so now it says that a student is chosen at a random from 100 students, and another student is chosen from the remaining students. So the second student is chosen from not from the 100 but the remaining. Find the probability that the first student studies history. So first student studies history and the second student studies geography but not psychology. So in the first, so probability of history, that will be how many are in history? 25 plus 3 plus 7 plus 8, right? So 25, we have to add all these of history. 25 plus 3 plus 8 plus 7. Okay, these are 43. So 43 out of 100 is the probability of history, and the second student studies geography but not psychology. So you do not have to increase, you do not have to include the students who are studying geography. So you have to include only those students who are studying geography, not psychology. So you do not have to include this one, right? So not psychology and studies geography. So the second student is 25 plus 12. So 25 plus 12 is it's the second student. So the first student he is taken, he is not included. So in that case, 12 plus 25 plus 12 is how much we have. 25 plus 12 is 37. So 37 out of 99, right? So if we solve this, probability should give us the answer 43 times 37. 43 times 37. Okay, 1591 over 9900, or if you simplify, divided by 9900, so 0.16. 0.16 is the probability of this question.